Okay, video number 3. Now I lost my timekeeper up here, so I'm going to have to try and use my iPhone to keep track of this. Now last video we did was about English to metric conversion factors, and one of the things that I mentioned is that there were certain eclectic values that you would just have to commit to memory. Now I want to show you up on the front wall here of the classroom. This is the most that I could say I'm willing to do to help you. If you look at the little numbers on there, you will see that there are numbers that correspond with the different conversion factors that we talked about in the last video. So those will always stay up on the board. So I will not tell you what units go with what numbers, but the values will be up there, and that's the most that I'm willing to, try and help you out as far as remembering those values, because you should commit them to memory. Okay, so the main theme for this video has to do with metric to metric conversion factors. And before we dive into that, I do need to point out I am going to reference some documents and worksheets during the course of these videos that are housed online at what I call my class web page. It is very lame, very basic, but it gives me a place to dump documents that when I say, hey, the document's out there, you can practice on your own, you know where you can go to access the documents. So I'm not going to give you the official URL because somebody created a bit.ly for me, and that's also up here on the board, but I'll write it out here. So when I reference the conversion factor worksheet or the prefix worksheet, this is the address that you can go to, and that will be the home page. I have two kind of subfolders, one for the regular physics class and one for honors physics, that's off on the left. And so if you go to this site, you'll see honors physics, and if you click there, you'll see another subfolder that talks about conversion worksheets, and if you click there, then you'll get a main menu that has a variety of documents there, and two of them that will be important at least up to this point in time. One is called conversion factors, which has a compilation of the conversion factors that I put up on the whiteboard in the last video, and there is another one that's called metric prefix worksheet that is some practice that you can do based off what you're going to see in this video here now. So you can bookmark that. And like I said, it's up on the board up here, so that anytime you need it, you can get to that. Okay, now one of the key things about a metric to metric conversion factor are prefixes. Now some people will go ahead and refer to these as the metric prefixes, but the truth is that the prefixes mean the same thing whether they're being applied within the metric system or to anything in the world around us. And this is where I'm going to say I would like to think that you have had some exposure to this, but I am going to kind of approach it in a different fashion, because when we need to do a metric to metric conversion, at least when we're structuring it on paper, some people are taught these really quick shortcut ways, like move the decimal place this many to the right or to the left. I do not accept that. When I want you to implement and make use of a metric to metric prefixes or a metric to metric conversion factor, I want you to create a mathematical expression that says one of this unit equals this much of another unit. Now this is where the metric system, being a decimal system that's based on the number 10, definitely comes in handy. because you will not have to memorize any kind of eclectic number like you did with the English to English or English to metric conversion factors, because every single conversion factor will take on the form of 1 of one unit equals a power of 10 of another unit. But that doesn't mean that you don't have to memorize some things here, because you have to memorize the prefixes. Now, there are 3 things at a minimum that you need to know about each of the prefixes. And I'm going to try and fit them all on this whiteboard. It's going to be pretty tight. And I'm going to erase this metric to metric thing so I can get just a little bit more space. And what you need to memorize is the name of the prefix, the symbol of the prefix, and then the multiplier. And I'm going to keep this small so that I can be sure that I fit all of this in here. Now, the truth is that there is an expansive list of these, but the ones that I am going to kind of hold you accountable for start with, I'll start with the multipliers. Start with a multiplier of E9. Now, you notice I'm doing a capital E9 here. On many calculators today, when you go to use scientific notation, which is really what this is kind of a shorthand version of, they don't use times 10, they use a capital E instead. And I have a class set of calculators for you to use here, so that when we do these problems in class, you're not allowed to use your graphing calculator. You have to use a 4-function scientific calculator, and I have calculators that you can use if you don't have one of those. And my class calculators utilize this capital E notation. So I am going to, anytime we deal with a power of 10, I try and use this capital E instead of a base 10. If you like to set your stuff up with a base 10, that is fine. But I'm going to try and be consistent and use E's when we're doing scientific notation in here. So our multiplier list is going to go from E9, and the next one down is E6. The next one down would be E3. Then we have E2, E1, and then we have E0, which is kind of the center of the list. And then from there, we will have prefixes that kind of mirror this, but with negative exponents. So there will be an E -1, E -2, E -3, E -6, and then E -9. And as I said, there are more above and below this, and there is a reason that I'm presenting this in a vertical fashion instead of a right to left fashion. Okay, now, names. For E9, this is our prefix giga, and the symbol for this is a capital G. And as I go through this list, I will tell you that anytime we're dealing with units or prefixes or powers of 10 where you're going to use this E notation, all of that is case sensitive. That means if you utilize a lowercase letter where there should be a capital one, I am going to ding you. You might be thinking the right thing, but when it comes to you presenting your work to somebody else and all they can do is look at what you put on the paper, if you mess up something that is case sensitive, it doesn't reflect too great on you. So, and this is where some people's sloppy handwriting, sometimes you have to try and be a little bit more meticulous so that I am sure that I have a proper capital letter. Okay, the next one down is mega, and that is capital M. The next one down is kilo, this is a lowercase k. Then for E2, I have seen hecto and hecta. I'll take, actually, I'm going to go with the hecta because of the next one. That is a lowercase h. Then we have deca, and I have seen deca with a CA and a KA. We'll just put a KA here. This one is, I think it's the only one on the list that is actually two letters. Lowercase d, lowercase a. When we get to E0, there is no symbol here because when it comes to having E0, this is whatever our base unit is going to be. Now, we mentioned last time that in the metric system for R3 basic, actually we'll do 4 because I have volume in there. The base unit for length will be meters. The base unit for mass technically is the gram because everything builds off of that. And then for, what do we have, time, it will be the second. And for volume, it would be the liter. Now, as we go here into the negative exponents, this one here for E-1 is a lowercase d, and that is for deci. E-2, lowercase c, and that is centi. E-3, lowercase m, and that is milli. E-6 is a Greek letter mu. I call it the curly m, and that stands for micro. And E-9 is lowercase n, and that stands for nano. Now, going back to my case sensitivity comment, you can see that on this symbol column, we have 3 different m's. We have a block capital M, we have a lowercase m, and we have this curly Greek letter m. That is why when someone tells you, oh, it's an M, okay, well, that could mean a variety of different things, and that's why being sure that people can read your writing properly is important. And when you take your lowercase m and you make it like this and go, well, that's my mega because I just made it big, that is not acceptable. I will ding you on that. Make a good, proper block capital M if you need mega. Okay, now, couple comments here, and I'll change colors on this. Just, I'll do it on this side. This collection of prefixes that have positive exponents on the E, I refer to those as big prefixes. Because if you paid attention in the last video, I talked about when you set up a conversion factor, there are 2 ways to approach this, but both approaches depend on your understanding of which unit is the big unit and which one is the small unit. And so when it comes to these prefixes, I refer to these as big prefixes because what this multiplier means is that if you put a deca, hecta, kilo, mega, or giga in front of a base unit, what you are doing is you are lumping together multiples of 10 of that unit. And that means when you talk about, 1 hecta anything, that is going to be bigger than 1 of the base unit. So it's like, this is where we get into the classic example I think some people draw upon for this is like pizza. So if our base unit is a pizza, if I talked about a hecta pizza, what that means is 1 hecta pizza is e to the second of a single pizza. And E2 is 100, so that means one hectopizza would be 100 pizzas all lumped together, but being treated as one unit. So that's what all of these prefixes do. They take a base unit and they lump multiples in powers of 10 together to create a bigger unit. And some of these you may be familiar with. If you're into computers, definitely with mega and giga. You know, when it comes to storage and speed of computers, they make use of these quite a bit. I will tell you, just to give away my age a little bit, I was around when computers first started to come in, and everything was, in terms of storage and speed, was with kilo. And as things have gotten faster and faster, the reason they make use of the prefixes is because if not, you're just going to have bigger and bigger numbers. And by making use of the prefixes, you can express a bigger number with fewer digits. And so it looks a little more normal sized. Okay, these prefixes down here, I refer to them as the small prefixes, because this is where the pizza analogy kind of comes in, because most people understand, yeah, I don't eat a whole pizza, I slice it into pizzas, and that's where you get into this idea of fractions. And that's the idea of what these prefixes do, except they do them in multiples of 10. So if I wanted to, again, going back to saying my base unit is a pizza, and I wanted to talk about a deci pizza, what a deci pizza would refer to is my pizza and 1/10 of that pizza. So that might be, it'd be kind of a small slice. If you went to a centi pizza, then you're talking about a minuscule piece, and it just keeps chopping it into smaller and smaller pieces. And the idea is that you're referring to only a certain number of those pizzas. So when you talk about a deci pizza, even though you have the idea, the picture in your head of a whole pizza, you're not really talking about a whole pizza at all. You are just referring to 1/10 of whatever that pizza is. So this here is what you need to memorize so that you can create any metric to metric conversion factor you need. Now, and again, in this class, most of what we'll be doing when I'm giving you quiz problems about unit conversions, they'll involve base units of meters, grams, liters, and seconds. But you can apply these particular prefixes to any base unit out in the world. So that's why when people refer to them as metric prefixes, kind of like, that they're not strictly metric things. These are generally accepted prefixes that can be used in any application. Okay, checking my time. Whew, 18 minutes. Okay, so now, how do you make use of this to make a metric to metric conversion factor? All right, here we go. Let's say, and I'm just going to use a base unit of a star. Okay, I'm not even going to worry about whether it's a meter, a liter, or a gram or whatever. Let's say that for some reason you need to be able to equate and get the relationship between a decastar and a millistar. Now, I'm going to give you a series of rules that you can follow. So I'm only going to do a couple examples, and then the conversion or metric prefix worksheet gives you about 15 practice ones that you can work on. So here is the rule, and I'm not going to write this down so you can kind of go back and rewind to listen to the rules. Rule 1 is when you have to make a metric to metric conversion factor, you have to determine which one of these is bigger. And this is where the verticality of the list comes into play. Because since I've organized it this way, whenever I'm comparing two prefixes on this chart, the bigger one is the one that's higher up on the chart. So that means between these two, I look upon the Deca star as the big one and the Milli star as the small one. Okay? Now, the next thing that I do, and this is where there are two approaches, but I'm only going to give you one, at least for practice, because I find that people are more successful with this approach than the other one. But if you get, I'll refer to the other approach, and if you go, oh, I get what you're talking about, you can use either one. I find the bigger unit, and I put a 1 in front of it. And on the other unit, I put the capital E, and that represents my base 10. And then I come to this chart and go, well, Deca is E1 and Milli is E negative 3. And what I think of is how far apart is 1 and negative 3 on a number line. Not worrying about is it a positive or negative direction. I'm always thinking positive here. But how far apart are 1 and negative 3? Now, if you wanted to get really picky, you could always say, I am always going to take the top or the bigger exponent and subtract from it the lower one, which in this case would be 1 minus a negative 3, which means we add the 3 to the 1, and we get 4. That is the correct relationship between a Deca anything and a Milli anything. 1 Deca something equals E4 Milli anythings. Now, if this is where I'm gonna gloss over this very quickly. If you approach this from what I call the opposite approach, that would entail you putting a 1 on the small unit and the E over here. And if you were to do that, what you would end up doing is taking the separation between the two, which is 4 spaces, but it would be a negative value the other way around. Now the thing is that, and I'll include the units here, both of those conversion factors are correct. They are just expressed in different ways. Whereas the top one is one big thing is multiples of a small thing, whereas the bottom approach is one small thing is a fraction of a big thing. So now, just to do one more practice example, and I'm just going to do it this way that I did in black up here, because I find that most people are more likely to get the correct mathematical relationship when you focus on one big thing equals multiple small things. Let's say, I'm going to do 2 other ones. Let's say we had a centi circle and a nanocircle. So again, between these two here, which one is the bigger one? Here's centi, here's nano. Centi is higher up, so that means centi now is the bigger unit. And that means when we go through the process here, once we establish this, the 1 goes with the bigger unit and the other side gets an E, and then we take the separation between the two, or if you're very rigorous, you could always say I'm going to take the higher up exponent and subtract from it the lower down exponent, which in this case would translate to a -2 minus a -9. Or you could just think, I'm at -2, I need to go to -9. How many steps or how many places would I have to move on the number line? Either way, you end up with a +7. Okay? Now, once you get the hang of this, this is a routine thing that you can create on the fly. And we haven't talked about actually setting up unit conversion problems yet, but you're going to need to do this. I'm going to make you do it based on the types of problems that I'll be giving you, where you'll have to create this on the fly so that you can set up the structure to do the calculation to get the answer. And this is a more detailed way compared to, oh, well, this means move the decimal place 7 places in a given direction. Okay, this is much more mathematically based because it gives you values that you can put into a mathematical expression that you can then calculate. Okay, so this is how you can make any metric to metric conversion factor. And again, you need to memorize something, which is this list, and I will hold you to that. But then you need to remember the rules for how you set these things up. And for practice, just to remind you, got to make sure that I think it is referred to as, on the class webpage, there is a document. I'm getting there. Got to bear with me. It is called Metric Prefix Worksheet. So you can take a look at that and you can practice this. I do not have a key, so you'll have to practice it. If you wanted to check with other people that you know who are in the class, you could see what were your answers, and then we can do some correcting on the first day of class. Because once you have this down, that's one less thing that you have to worry about as far as doing unit conversions and getting the answers correct. Also, just so that, and I think I mentioned this earlier, if you go there to do this, there is also a document called Conversion Factors, which lists the actual conversion factors that I referenced in the last video. And there is a PDF that is called Metric Prefix Chart. And that shows you a complete listing of all of these. I think the multipliers go all the way up to E24, and they go down as far as E-24. And I'm going to point out one last cool thing, to connect here. You'll notice that when it comes to the multipliers, you have multipliers to cover 10, 100, and 1,000, a tenth, a hundredth, and a thousandth, but from there, you jump by 3. And if you think about this, the reason for this jumping by 3 is how we write numbers. Because when you write a big number, once you hit 3 place values, you place a comma. And every 3 place values, you place a comma. So the idea is that the first E1, E2, E-1, E-2, that allows you to access a quick kind of shorthand way of getting tens and tenths and hundreds and hundredths. But from that moment on, you can just go by powers of 10, because there actually is a way where you can combine multiple ones of these. So for example, if you needed E5 for some reason, what you would do is you would combine hecta and kilo, and the prefix, I think it would be a hectakilo something, and that would be your E5. Kind of eclectic, but I have seen it in a couple places where you use multiple ones of these. But that's why you don't need an E4 or an E5 or an E7 or an E-5, because you could combine these if you needed to together to get that particular multiplier. So that's just kind of a cute little thing that can pop up. Okay, 3 down. Once you got all of these first 3 videos, now we're going to get into setting up unit conversion problems, and we'll start to get into some math stuff. So, thanks for hanging in there. See you next time.